So how you been, Remy?
Good, how about you?
I've been pretty good. How's physics so far?
It's really hard.
It's hard?
Yeah, it's one of the hardest classes I've taken, I feel like.
Really? Yeah, that's true. But this food is really good. You should grab a bite.
My stomach has been hurting really bad.
Are you sure?
Yeah.
Just grab a little bit, like this little piece right there.
No, I'm good.
No, please, just take a little bit.
Okay, fine.
How is it?
Ow.
Wait, are you okay?
No.
Someone call 911. Ramya, can you hear me? Can you hear me? Are you okay?
What happened?
You were rushed to the hospital because you have an ulcer and we took a look at it through an endoscopy.
What is an endoscopy?
Oh, I'm glad you asked. Nurse, can you please show what endoscopy is like? So you're interested in looking at what endoscopy is. Let's take a look. The primary tool of an endoscopy is an endoscope, typically used to examine the esophagus, digestive tract, and other organs. Now I'll explain what an endoscope is and how it works. An endoscope is a narrow, flexible tube of optic fibers that feeds images from inside the body back to a TV monitor. An endoscope employs total internal reflection by bouncing light from one end of the optic fiber bundle to another. Total internal reflection happens when you bounce light waves from a medium with a high index of refraction, such as a glass or plastic, to one with a lower index of refraction, such as air. This causes the light ray to bend away from the normal.
In order to have internal reflection, the angle of incidence of the incident light ray must be smaller than the critical angle. The critical angle is the angle at which light is no longer refracted in the medium. When the angle of incidence is larger than the critical angle, a portion of the light is refracted and a portion is reflected. However, when the angle of incidence is lower than the critical angle, there is no light refracted. In this way, all light that passes through is internally reflected back into the medium.
In the case of the endoscope, the narrow tubing allows for continuous random reflection of light rays so that you can get light all the way inside the body. The endoscope has two kinds of fibers, non-coherent fibers that don't line up and coherent fibers that line up to transmit an image. Non-coherent fibers guide the light towards the end of the tube while coherent fibers guide the transmitted image back towards the lens. The transmitted image is then seen by the doctor through the eyepiece.